Good day, grade 8s. I hope that you are doing well. Today we are going to dive into our new section of exponents. Right. So exponents is very interesting because we came across exponents specifically in grade 6 and 7. So let's first understand what an exponent is. So for example, let's say we have 2 raised to the power of 5. Now that's how we read this, as 2 raised to the power of 5. Now what's interesting is that I can see that there's a 5 that's superscripted to the 2. Superscript means that it's a small number that's placed on the top of this 2. This 5 is known as the exponent. Right, so this is what we call the exponent. The 2 that's at the bottom, right, is known as the base. Right. So what is an exponent? An exponent tells us how many times the base is being repeated. So let's write that down. The exponent tells us how many times the base is being repeated. So as I mentioned, we read this as 2 raised to the power of 5. The exponent is 5, the base is 2. So by our definition, this means that the base 2 is being repeated 5 times. So we have 2 raised to the power of 5 is equal to 2 times 2 times 2 times 2 times 2. The base of 2 is being repeated 5 times. And we can calculate that as such. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So 2 raised to the power of 5 is 32. And what I observed while teaching is that many scholars actually do this. They say 2 raised to the power of 5 and they say 2 times 5, which is 10, and they write the answer as 10. That is incorrect. 2 raised to the power of 5 is not equal to 10. You do not take the base and you do not multiply it to the exponent. The exponent, as I said, it tells us how many times the base is being repeated. So let's take another example very quickly. Let's say we have 5 raised to the power of 3. Now 5 raised to the power of 3 means that the base, which is 5, so let's first classify what's the base and what the exponent before I continue. The base is that bottom part, which is 5, and 3 is the exponent. Right? It's the number that's superscripted on the top. Superscript basically means that it's a small number that's placed on the top. This means this is read as 3 raised to the power, as 5 raised to the power of 3, or we can say that this is 5 cubed. So if you think about a cube and you want to calculate the volume of a cube, you take the length multiplied by the breadth multiplied by the height, and you get a number cubed. So likewise, that is why we call it cubed. And when it comes to squaring a number, now when we talk about a square, it means that we multiplying a number by itself. The base is being repeated 2 times. So for example, 5 squared basically means 5 times 5, which is equal to 25. This is basically, we have a square, and if we want to calculate the area of the square, area is length times breadth, and let's say both, we know that the lengths or the sides of a square are equal. Right, that's one of the properties of a square. So this is 5 units, this will also be 5 units, so the area is 5 times 5. But when we get to area in term 3, this will make more sense. But for now, you should know that you can read 5 raised to the power of 2 as 5 squared, and likewise you can read 5 raised to the power of 3 as 5 cubed. And the exponent tells us how many times the base is being repeated. The base 5 is being repeated 3 times. So this is equal to 5 times 5 times 5, which is equal to 5 times 5 is 25. 25 times 5 is 125. Now again, many scholars they see 5 raised to the power 3, and then they multiply the base by the exponent, which is incorrect. It is not 5 times 3, which is 15. Instead, it is 5 times 5 times 5. So, great. Now we have a clear understanding of what the base and the exponent is. Now, just like how in South Africa we have the Constitution, where it is made up of these different laws that govern our land, the law exponents also contain some laws, and we're going to look at each law. Let me just write this on a new page so there's nothing in the back. Each law, there's many laws of exponents, and we're going to look at each one as we go on in class. But I'm just going to just give you a quick summary of all the laws that we're going to look at. So we're at laws of exponents. Let's look at the first law. Now, I'm not really a fan of numbering or labeling the laws like law 1, law 2, law 3, because I like that we can apply these laws without specifically memorizing which is law 1, which is law 2. But nevertheless, let's just start by saying, let's look at the first law, the one that's most commonly used, for example. Now, we established that there's certain laws to exponents, and when I teach the laws of exponents, I conduct investigation, so you need to discover this for yourself. For example, if I have 2 raised to the power 5 times 2 raised to the power of 3. So my first question to you is, what is the base of 2 raised to the power of 5? Now I hope your response is that 2 is the base of 2 raised to the power of 5. What is the exponent of 2 raised to the power of 5? Of course, it's 5. So by now, this looks quite simple, right? Next, we have multiplication, right? This is not addition, this is not division. For now, we are dealing with multiplication. So we take a value and we multiply it to another value. So this second value that I can see here has a base as well. The base is also 2, and the exponent is 3. So what can I observe when I'm multiplying these two? I can observe that the two bases are the same. So I'm multiplying two values that have a common base, that have the same base. In this specific example, the common base is 2. Now, let's calculate this. 2 raised to the power of 5, we know that 2 raised to the power of 5, as we said, is 32, times 2 raised to the power of 3, or 2 cubed, is 8. So I'm just going to use my calculator to calculate this. 32 times 8 is 256. Right, so that's what happens when we calculate this. Right, 2 raised to the power of 5 means 2 times 2 times 2 times 2 times 2. 2 is being repeated 5 times. 2 cubed means that 2 is being repeated 3 times. So that's 2 times 2 times 2, which is 8. Multiplied these two out gives me 256. Now, this is not specifically the law, but I'm getting to a point. What if, now this is the question, 2 raised to the power of 5 times 2 raised to the power of 3. What if we expand this out? So I'm going to use different colors to actually show you this. Let's use blue and purple. I have 2 raised to the power of 5, so let's expand that out. I know that 2 raised to the power of 5, let's shift this light higher. I know that 2 raised to the power of 5 is 2 times 2 times 2 times 2 times 2. The base 2 is being repeated 5 times. I know, I'm going to use purple now, that 2 cubed means that the base 2 is being repeated 3 times. So that's times 2 times 2 times 2. So what I can see here is that I have 2 raised to the power of 5 being multiplied by 2 raised to the power of 3. Now, we said that the exponent basically tells me how many times the base is being repeated. So I can write this expanded multiplication in terms of an exponent as well. Let's count how many 2's is being repeated. 1, 2, 3, 4, 5, 6, 7, 8. So this is 2 raised to the power of 8. Agreed? So what we can conclude is that 2 raised to the power of 5 times 2 cubed is equal to 2 raised to the power of 8. That's what we have. Now we can investigate this with a couple of other things. For example, we can see that 3 raised to the power of 3, or 3 cubed, times 3 raised to the power of, let's say, 6, and I expand out 3 cubed and I expand out 3 raised to the power of 6, it will give me 3 raised to the power of 9. And you can do this investigation with other numbers as well. Let's say 5 raised to the power of 10 times 5 raised to the power of 2. So this is going to be 5 times 5 times 5. 5 is going to be repeated 10 times, multiplied by 5 times 5. 5 is going to be repeated 2 times in this case. And then I'm going to see how many times 5 is being repeated. 5 will be repeated 12 times. So this is equal to 5 raised to the power of 12. Now I'll ask you, what do you observe from this investigation? Because that is how you discover maths. Maths is about discovery learning. What I can discover is that when I multiply and the bases are the same, I simply add the exponents. So I retain the common base, right? And I just add the exponents together. So if I have a, which is any real variable, raised to the power of m, which is any real variable as well, I hope that a and m are both not 0, because 0 raised to the power of 0 is undefined, right? Multiplied by a raised to the power of n. Now, the common base is a, so we retain the common base a, and we simply add the exponents together. So a raised to the power of m times a raised to the power of m is equal to a raised to the power of m plus n. And this is known as the first law of exponents. So let's look at some examples. I know we looked at some investigations, but let's just look at some nice examples that will help us. So let's look at example 1. Right, example 1, I have to simplify. Usually there's an instruction for each question, so let's simplify or calculate. Let's say we have 3 raised to the power of 4 times 3 raised to the power of 2 times 3 raised to the power of, let's say, 3. Right? So that's 3 cubed. Now, I notice that I have a common base. The common base is 3. So I keep the common base as 3 and I simply add the exponents together because I am multiplying. So it's 4 plus 2 plus 3. That is equal to 3 raised to the power of 9, because 4 plus 2 is 6, 6 plus 3 is 9, so that's 3 raised to the power of 9. And usually sometimes if they state that you should leave your final solution in exponential form, this is what they mean. You have a base raised to a power. Let's look at one more example. I have x raised to the power of 5 times. Now this dot means times. I like to use a dot whenever I'm using x, because I notice that some students, they confuse multiplication with the variable x. They draw it, they write it almost exactly the same. The variable x, which represents any real number, is just drawn a bit cursive, I won't say cursive like, but it's more curved, and it's raised to the power of 5. So let's just use a dot now to show multiplication, times, let's say, y raised to the power of 2 times x raised to the power of 2 times y raised to the power of 5. Now in this case here, I have x raised to the power of 5 times y squared times x squared times y raised to the power of 5. Now I know that multiplication, there's a property that we learned in term 1 known as the commutative property of multiplication. Right? Remember, the commutative property also applies to addition, but in this case we are multiplying. So I can even rearrange this as x, this is equal to x raised to the power of 5 times x squared, right? That is being multiplied by y squared times y raised to the power of 5. I'm not changing the value of the question, I'm just rearranging everything so that the x's are together and the y's are together. You do not need to even show this step. You can just say that x raised to the power of 5 is being multiplied by x squared, and that y squared is being multiplied by y raised to the power of 5. But I'm showing you that I can jumble everything around, and which actually makes everything look much more presentable. Let me just bring this up a bit. So I have x raised to the power of 5 times x squared, which is x raised to the power of 5 plus 2 times y raised to the power of 2 plus 5. So it's x raised to the power of 5 plus 2 times y raised to the power of 2 times 2 plus 5. Why? Because I'm multiplying these two together and they both have the common base of x. And I'm multiplying these two together and they both have the common base of y. So this is equal to x raised to the power of 7, y raised to the power of 7. Now you might say, why isn't there an operation in between these two variables? Well, there's an invisible or implied multiplication. So if I tell you what is AB, for example, AB actually means A times B. There's an invisible multiplication that is happening between these two variables. So I do not need to necessarily show something in there. And the number that's in front of variables, the number or the values that's in front of a specific variable, for example, in this case, we have x raised to the power of 7, y raised to the power of 7. The number that's in front, it is an invisible 1 here. So this number is known as the coefficient. So do not forget that there's an invisible 1 there as well. So you will learn more about that when we look at algebraic expressions very, very soon. But that being said, I just want to quickly just explain one more thing. Let's look at example 3, the last example, and then we move it out of there. I have a times a raised to the power of 5. And I ask you, what is this equal to? Now, we should not forget that there's an invisible exponent by the a. This is a raised to the power of 1. So now I can apply the first law. When multiplying and the bases are the same, we added the exponents together. So this is a raised to the power of 1 plus 5, which is equal to a raised to the power of 6, and that's your final answer from there. So this sums up the final, or not the final, but rather the first law of exponents. When multiplying and the bases are the same, we add the exponents together. The second law has to do with the division. Now I'm not going to look at the investigation with you. I will look at it in class, but the second law states this: if we have a raised to the power of m, let's just call this second law, right? Let's call this the second law of exponents. Again, I'm not a fan of numbering exponents, right? I know some teachers are, but as long as you can apply the exponents is fine. In the exam, I will never ask you what state the second law of exponents. No, I will give you an example and I will expect that you can actually apply the second law of exponents, so that specific law of exponents. So as long as you know the law, it's fine. So it's a raised to the power of m divided by a raised to the power of n. Now this looks completely different, or slightly different from our first example. In the first example, we said when multiplying and the bases are the same, we can add the exponents together. In this case, we are dividing and the bases are the same. What do we do to the exponents? So again, we can conduct an investigation, which I will conduct in class with you. But for now, due to time, this is what the law states. When dividing and the bases are the same, we subtract the exponent. So we take the first exponent, m. It does not matter if m is smaller than n. We still take the first exponent and minus the second exponent. So the second exponent is being subtracted from the first exponent, basically. So let me show you an example of what I mean. For example, if I have 2 raised to the power of 10 divided by 2 raised to the power of 5, this, now I can apply the law. When dividing and the bases are the same, what is the common base between these two? It is 2, so we keep 2. Right? We do not say 2 divided by 2 and keep and write the quotient as 1. No, we keep the common base, which is 2, and then we take the first exponent, which is 10, and we subtract it from the second exponent, which is 5. So this is equal to 2 raised to the power of 5, which is 32. But again, if the question states that you should leave your answer in exponential form, this is perfectly fine. 2 raised to the power of 5. Now, do not forget that division, a fraction, is essentially the same thing as division in maths. right? So I can rewrite this 2 raised to the power of 10 divided by 2 raised to the power of 5 as 2 raised to the power of 10 over 2 raised to the power of 5. This is the exact same question, right? The division means that the numerator divided by denominator. So this is going to be equal to, again, I'm going to keep the common base of 2. I'm going to take the first exponent, in this case it's going to be the exponent of the numerator, which is 10, minus the exponent of the denominator, which is 5, which is equal to 2 raised to the power of 5. And that's your final answer from there. So let's look at another example very quickly. Let's say I have x raised to the power of 10, y raised to the power of 5 over x raised to the power of 2, y raised to the power of 3. Now in grade 9 we will look at examples where we have a negative exponent and how do we deal with that, but in this case we are only looking at, or mostly looking at, exponents with the exponent where our answer will have positive exponents, right? So in this case I have x10 y raised to the power of 5. What's happening in between these two variables? As I said, multiplication. It's x raised to the power of 10 times y raised to the power of 5 all over x squared multiplied by y raised to the power of 3. So I know that we multiply fractions top of the top, bottom of the bottom. In term 1 we actually looked at that. For example, if I have a raised to the power, a over b times c over d, how do I multiply these fractions out? I multiply top of the top, bottom of the bottom. The numerators multiply numerator by numerator, all over denominator by denominator. And then, of course, my final answer I can simplify from there. Whenever it comes to fractions, do not forget to simplify the final answer. But in this case, I'm dealing with variables, so I cannot really simplify that much. It's going to be AC, which means A times C, all over BD, which is B times D, and that's your final answer. So what I can do is that I can get from the final answer and I can break it up as such, and I think I'm going to do that because it makes my life slightly more easier. This is x raised to the power of 10 over x squared times y raised to the power of 5 over y cubed, and I always say that the equal to sign is extremely important. It means that these two are equal with each other, and let's see if it is. Remember, you multiply top of the top, bottom of the bottom. X raised to the power of 10 times y raised to the power of 5 is x raised to the power of 10 y raised to the power of 5. All over, now you multiply denominator with denominator, or the bottom of the bottom, x squared times y cubed, and that is the solution from there. So now we're going to look at each fraction, and we said a fraction is the exact same thing as division, and we just learned that the law states that when dividing and the bases are the same, we subtract the exponents. So that's what we're going to do in this case. Right, so we have x raised to the power of 10 over x squared, which is equal to, I'm going to keep the common base, which is x, and we'll take the exponent on the top, 10, minus the exponent at the bottom, which is 2, times, now I'm going to look at this fraction, which is y raised to the power of 5 over y cubed. I'm dividing, and the bases are the same, so I keep the common base y and I subtract the exponent. First, the first exponent, which is 5, minus the second exponent, which is 3. And that is equal to x raised to the power of 8, y raised to the power of 2. And that's your final answer, which means x raised to the power of 8 times y raised to the power of 2. And you might ask, what is this x and y that I keep on referring to? As I said, it can mean any real value. X can be 1,000, x can be negative a half, x can be 3, it can be 2, it can be 0, it can be any real value, right? So as I said, just be careful when you say it's any real value. In this case, both a and m cannot be 0 at the same time, because 0 raised to the power of 0 is undefined, so just be careful with that. But usually when it comes to variables, they are constrained. When we start learning about algebra, I'll get into more detail with that. So you can even check to see whether your answer is correct in a calculator. I can give the value of, okay, let's do that very quickly. I want to show how cool this actually is. Let's say x is 2 and y is 3. I'm giving it any value, right? Hypothetically, x is 2, y is 3. Now this is just for my own record, just to see if my work is correct or not. So wherever I see x, I'm going to substitute x for 2. Wherever I see y, I'm going to substitute 3 in the place of y. And whenever it comes to substitution, we use brackets. So it's going to be x raised to the power of 10, so that's actually 2 raised to the power of 10. Now this is just for my own purposes, just to check my work, times y raised to the power of 5, which is 3 raised to the power of 5. Now in the denominator, I have x squared, which is 2 squared. That is x2 squared, right? And I have y raised to the power of 3, which is 3 cubed. Let's press equal to, and that gives me the answer of 2,304. Now, this should be equal to, you can see the equal to sign. That is why I tell learners all the time, it's extremely important how you lay out your work. The equal to sign, do not take it for granted. Do not show me one working out. Do not say this is equal to and then calculate x, then put an equal to again and then calculate y, and then your final answer is equal to. No. All steps have to follow. Math is a language. So this is 2,304. Now let's look at the solution. The solution is x raised to the power of 8 times y squared. So in the place of x, I'm going to substitute that with the 2. So that's 2 raised to the power of 8, right? Y, which is 3 squared. And that is also equal to 2,304. So you can see that they are equal to each other. You just simplify it, and that's what the question asked us to do. So just for today, I explained the two laws. So let's just quickly recap. When multiplying and the bases are the same, we add the exponents. So that is when we multiply. When dividing and the bases are the same, we subtract the exponents. So those were the two laws that we covered. There are many more laws, like for example, an exponent raised to a further power. There's raising a base to the power of 0, and there's many more to that, and I will explain that in due time. Thank you for watching.